Welcome. Today we're going to be talking about the three states of matter and how we can change things from one to the other by asking what seems like a very simple question. You can see these lighters contain a liquid. When you press the release button down, a gas comes out. My question is, how can a humble lighter change a liquid into a gas? Before you try and answer, let's clarify the question. Most of the time it is said that there are three states of matter. Matter is just the stuff things are made of. The seat you're sitting on, the table, the ceiling, even the air is made of stuff. The science word for stuff is matter. Matter can be in three different forms: a solid, a liquid, or a gas. Let's use water as an example. Water can be solid in the form of ice. It can be in a liquid form, which is most of the time. Or it can be a gas. But let's make sure we know exactly what we're looking at there. This bit, the white cloudy area, is not what we are talking about. This is water vapour, minuscule droplets of liquid water. We are not talking about liquid, we're talking about the gas. The invisible bit is the gas. With water we usually call it steam. All gases are invisible. That is the part we're talking about, an invisible gas. We usually need to add lots of cold to turn a liquid into a solid, or lots of heat to turn a liquid into a gas. So back to our original question. How can the humble lighter boil a liquid into a gas instantaneously without adding lots of heat? You might want to pause the video to think about this for a moment or discuss with your class. But how do you know I'm not playing a trick on you? Are we sure a gas comes out when you press the button? I'll show you next in a little video I've made. I have dimmed the lights for this experiment for reasons you'll see in a moment. I have a bowl and a button pressed down on a cigarette lighter. You can't see any liquid dribbling out, but is there a gas coming out? Can we be sure? We'll keep watching. Do not try this one yourself. The skin on my hands is very hard and tough. Children's skin is very soft and delicate. You could give yourself some very nasty burns. But it does demonstrate there is a gas coming out. You might like to pause for a few moments before I start giving you some clues. Most people already know that water boils at 100 degrees Celsius. A scientist will say it slightly differently. Water boils at 100 degrees Celsius at sea level. An interesting fact to know while you're thinking about this is that the top of Mount Everest, water boils at only 71 degrees Celsius. Does that give you enough of a hint? The yellow writing shows us that there is about 480 kilometres of air above us. The green arrow shows that Earth's gravity pulls that air down to the surface, with the heaviest parts of air, like nitrogen and oxygen, down low, and the lightest parts of air, like hydrogen and helium, much higher up. The weight of all that air above us creates a pressure that pushes on every surface you can think of, the ground and even our bodies. It works out to 1 kilogram of pressure for every square centimetre. Have a look at your hand and try and think how many square centimetres will fit on the back of your hand. I have big hands, so it has 100 square centimetres on it. That means there is 100 kilograms of pressure on the back of my hand. Think about how many square centimetres would fit on your chest, or even across your whole body. We don't usually notice this pressure because it is there constantly, and our bodies grow in such a way as to push outwards so it doesn't squash us. That's why you don't leave your spaceship without a pressure suit. You would blow up like a balloon, at least as far as your skin stretches. I don't imagine that would be very comfortable. Air pressure is measured in pascals. The purple writing to the right of my beautifully drawn stick figure shows us that the boiling point of water is 100 degrees Celsius at 100 kilopascals of pressure. Mount Everest is 8,840 metres high. There's very little oxygen at the top of Mount Everest because the heavier stuff falls further down. So there is nearly 9 kilometres less air above you when you are standing on the top of Mount Everest. The boiling point of water at the top of Mount Everest is 71 degrees Celsius at 34 kilopascals. Does this give you more of a hint of what's going on? At the top of Mount Everest, the air pressure is low and the boiling point is low. At sea level, the air pressure is high and the boiling point is high. I'm pretty sure you've worked it out by now. Yes, butane lighters are packed under high pressure. That is why children shouldn't touch lighters. If they are roughly treated, that pressure can come out very quickly in a big bang. The high pressure increases the boiling point of the butane so that it is forced back into its liquid state. A simple question with a not so simple answer, but the end of it all is pressure affects the boiling points of different substances.